All right, so this is your sample problems for F equals MA, and I want you to use guess still. Okay, so you're still using guess. And you may think, oh, but why? It's so simple. I am not working on making sure that you remember using guess for any other reason than that equations on the next unit, there's going to be 6 of them at the same time. So I got to make sure that you know how to use this now, because when it gets harder, I want to make sure that you are not lost. A quick review on F equals MA. F is the force, and it's going to be in newtons. Make sure you're writing everything I'm writing. M is the mass, and it is going to be in kilograms. A is the acceleration, and it's in meters per second squared. You need to know this in order to be able to find the givens and unknowns. Okay? So we read the problem and it says, with what force will a car hit a tree if the car has a mass of 3,000 kilograms and is accelerating at a rate of 2 meters per second squared? So here's the information we're looking for. So the force is going to have to be in newtons. The mass should be in kilograms, and the acceleration in meters per second squared. So you're looking at this unit, and you determine 3,000 kilograms has to go here for mass, because that's what mass, that's the unit for mass. And then you read here, it says it's accelerating at 2 meters per second squared. Well, that belongs in the meters per second squared, which is the acceleration. And this is the information I am looking for, so I'm going to mark it as X. So now I wrote my givens and unknowns. Check. The equation, right now we're only going to have one, F equals MA. There will be another equation added on, but not just yet. And then we just substitute and solve. So F, you could either replace it as X or leave it as F. I'm going to leave it as F for now. And then for M, I'm going to change it to 3,000. And acceleration, I'm going to change it to 2. So 2 times 3 is 6. Add on the rest of the zeros. The force is 6,000 newtons. Problem 1 is done. So still referring to my table that I created, I want you to pause the video and list the givens and unknowns. As soon as you are done with listing the givens and unknowns, go ahead and unpause the video and let's see if you got the right answer. All right, so for acceleration, again, that number should be in meters per second squared, and mass is going to be in kilograms, and force is going to be in newtons. So when I read this, what is the acceleration of a softball? If it has a mass of 0.50 kilograms, that goes here, because I know that's kilograms. And then 25 newtons is your force. So I must be looking for acceleration. There's always only one unknown. Never are they going to give you more than one unknown, because then it becomes impossible to solve. Okay? So here we did our givens and unknowns. Give yourself a high five if you got it right. And then equation is the same one here. We are only using this equation right now. And then you're going to substitute and solve. So 25 instead of F. M is 0.50. And then I'm going to go ahead and write it as X, because a lot of students tell me that if it's anything else, they get confused. So how do I solve for this? This is very simple. This is a one-step algebraic problem where you divide the number next to the variable to both sides. Here's the number next to the variable. Divide 0.50 to both sides. 25 divided by 0.5. Go ahead and put it in the calculator. And then pause the video, put it in the calculator. And then let's see if we get the same answer. And if I'm not mistaken, 25 divided by 0.5 is the same as multiplying it by 2. So you should have 50 as the acceleration, which is in meters per second squared. Then the next problem, what is the mass of the truck if it's accelerating at a rate of 5 meters per second and it hits a parked car with a force at 14,000 newtons? So again, write F, ma, and I recommend that you say, well, this is in newtons, so whatever this number is goes here. Anything that says newtons up here, like 14,000, then you write it here, 1, 2, 3. So this one says meters per second squared. Well, I know mass is in kilograms based on my table up here. So this is not it. But the next number is meters per second squared. So now I know that meters per second squared is 5 meters per second squared. Sorry, I pointed out the wrong thing first. And then kg is what you are looking for. So there you go. We did the givens and unknowns. The equation is the same, F equals ma. And now I want you to pause the video and see if you can substitute correctly into F equals ma. Okay, now that you unpause the video, you should have written 14,000 equals x times 5. This sometimes confuses students. This is the same as 14,000 equals 5x. There is no difference here because multiplication property, you can multiply numbers in any order as long as it's all multiplying. So 5x, and then it becomes the same problem as up above. So you are going to divide 5 to both sides. So go ahead and put it in your calculator. 14,000 divided by 5. And I have that the mass of this object is 2,800 kilograms. But wait, there is more. Let's talk about those relationships that we talked about earlier. So F equals ma. There's one way to remembering these relationships. If an object is on the same side of the equal sign, like mass and acceleration, if they're on the same side of the equal sign, they are an indirect relationship. So they are on the same side of the equal. And when one increases, when one variable increases, the other will decrease. That's what indirect means. They do the opposite. So when one variable increases, the other one is going to decrease. So again, for F equals ma, since mass and acceleration are on the same side of the equal, if we increase the mass, the acceleration is going to decrease. And vice versa. If you decrease the mass, the acceleration is going to If you decrease the mass, the acceleration is going to increase. However, if numbers, or if variables, are on opposite side of the equal sign. So now these are on the opposite sides. But we're focusing mainly on force and acceleration. So force and acceleration is our next focus. These are on opposite sides of the equal. They are directly related, which means that when one increases, the other one will also increase. Okay? This is because it's a direct relationship. So now if you look at F equals ma, if we increase the force, then the acceleration is going to increase. True story though, now that I have this here, let me use a different color, is that these are directly proportional. So if force doubles, then the acceleration is going to double, and that means double. If the force becomes 1/2, then the acceleration is going to be 1/2, okay? But for this equation, where you are looking at an indirect relationship, if the mass doubles, then the acceleration is going to do the inverse property. The inverse property is 1 over this number, okay? So the inverse property. The inverse property in math says that this is now going to become 1/2 times. It's the reciprocal. Remember that every number technically has a 1 underneath. So now we're going to flip it, and it's going to be 1/2 for the inverse of acceleration. Likewise, if your mass now is only 1/3 of the mass, let's say you were taking a load somewhere, and now the mass is 1/3, the acceleration is going to be the reciprocal, so you switch these numbers over, and now it's 3 times. So acceleration now is going to be 3 times the amount. You're going to use these notes or these sample problems to solve for problems in class. Make sure that you are able to do that.